continuing our discussion of heap buffer overflows, we're looking at the program we just presented in immunity. So I've already set a breakpoint right before my heap create method. And I'm going to go ahead and I'm going to run my program right up to that point. And a couple of things you should note. Here, I am copying my value of 40,000 into my stack. So I am allocating space on the stack and I am copying my values in. So remember the parameters I had for my program. And if I switch back to my program, you will see those parameters. So here's my first parameter, hex 40000, and then 0 and 0. And remember that we talked about calling conventions, and we said the calling convention was that you passed in those variables from right to left. So you can see that we're going backwards, passing those variables. And then here we call our heap create function. So I'm going to go ahead and step over our heap create. And now I have called that method. And you can see on the stack, there are certain things that are being displayed. In immunity, I can look at some of these heaps by executing the command !heap. And when I do so, I will see that there are several heaps that have been defined. So what are these heaps? Here's one of them. This is the default heap. And then these other heaps are heaps that are defined by some of the library code that's being called. So this is pretty typical for a Windows program to do this. Then I have a heap at 480000 that has been created. And that is my new heap. I can get additional information by adding to my heap command -h and then our address 480000. And now I can see that I have some more information that's being stored here. This is storing information about the chunks of memory that I'm using. So here's how this works. When I allocate little bits of memory, if it's a little bit under a kilobyte or less, that's what they consider a little bit of memory. So the first part of my heap has a couple of structures in it. And the first one is called a free list in use. And you see that right here. This is what we call a singly linked list. And that singly linked list means that every chunk has a pointer to the next chunk. So it's singly linked because you can traverse this list in one direction. You can start at the first chunk and go to the next and to the next. So if you look here, you will see this information is displayed. I start here, then I go to the next chunk. It is telling me where these different memory locations are, and that is the heap. Now, if I have smaller chunks, I will store those chunks that are available in something called a look-aside list. The look-aside list is similar to the free list, except for this is a doubly linked list. So what that means is that each chunk has a pointer to the next chunk, as with the free list, but it also has a pointer to the previous chunk. And each pointer requires 4 bytes, it's 32 bits. And what that means is that in memory, there will be 8 bytes for these pointers for every chunk. And we'll come back to that later and why that's important. So this is how we can look at our memory and how it's allocated. So I'll go ahead and close this for now. And I'm going to continue with my program. Trace again. So I've called heap create. Now I'm going to allocate some memory, just 16 bytes. I'm going to do that again. And I'm getting ready to free my first chunk. Now I have another command called look aside. So if I put in !look aside, it will tell me that it has dumped the look aside buffer. and it seems to have misplaced it. We'll look at this in more detail in the next video, actually. But I can get some information. So here's a little memory map that I have. I can look at a few other items. And here there's a nice message about failing to grab some memory at this location. Okay, so if I continue my trace here, I free and then I use stir copy, it gives me an access violation because it didn't like what I passed in. I exceeded my buffer and it failed. So now it says I have an access violation. We're going to take a little break, and when we come back, we're going to look at ways to potentially exploit this.